Hello guys. So today we're gonna learn about number systems. Number systems are basically the different um, like bases that you have. So we have a base 10 number system right now, um, and we're gonna be able to convert it to binary, which is base 2, that has 0 and 1. Octal or base 8, which is 0 to 7, and hexadecimal or base 16 goes 0 to 9, but it also goes to 10, 11, 12, 13, 14, and 15. And those 10 to 15 corresponds to a letter. So that's actually something you learn to memorize after a while. But I'm not really going to get into anything major, but I'm just going to teach you one foolproof way to convert from base 10 to base anything else. So let's start with a number that I like the number 45, because it's a cool number. So the number 45, um, let's convert that to binary. And a little subscript means binary. And this answer, I'm going to give room for the answer right here, and I'll tell you why later. So we start with 45. What we do is we divide by whatever base that we want to convert to. In this case, the base that we want to convert to is base 2. So this is 22 with a remainder of 1. So that remainder 1, the remainder 1, that's important. You put that right there. So, and then we take whatever's left. In this case, this is the 22. And we divide the 22. And we keep dividing until we only have a numerator. We don't have, I think that's called a quotient. We don't have a quotient in there. So 2 by that is just 11, remainder 0, and we put it there. Now keep in mind, I'm putting in the answers for these. It's like we're getting the answer kind of backwards. We're working right to left, not left to right. That's important. I messed that up a little while ago, and that was bad. So now we divide by 11. 11 divided by 2, that is 5, remainder 1. You put a 1 there. So 5 divided by 2, that is a 2 with remainder 1. So we put a 1 there. So now 2 divided by 2 is 1 with a remainder 0. So that's a 0. And now we have to just divide by that last 1. So we divide that last 1. We get 0, remainder 1. And that is our answer. Guess I left a little too much room, but that is our answer. So let's actually now convert to base 8. So 45 to x base 8. So like x should have left more room. Actually, yeah, let's fix that. So 45 to base 8. That's x equals whatever. Just gonna leave room for it. It's 45. And like we said before, you divide by whatever base. And this is base 8. So we divide by 8, and that goes, let's see. Well, that goes 5, remainder 5. Now you can do the math. I mean, this is the second time I'm going through this, so I already kind of know the answers and stuff. But you can do the math if you want. But I'm just telling you that it's 5 with the remainder 5. Remember, we put it in backwards. Put a 5 there. And then we have to divide by the quotient again. In this case, it's 5 divided by 8, and that's 0 with a remainder of 5, and we put a 5 there. So that's our answer in base 8. It's 55. So what's our answer in hexadecimal? So let's do 45 equals x in base 16, x equals, and I'm going to leave a little bit of room, so 45 divided by 16. This is 2. All right, what is 30? 45 minus 32, 13. So it's 2 remainder 13. However, we can't put 13 because in hexadecimal, it's not 13. In hexadecimal, it is actually D, okay? Because this is 10, A is 10, B is 11, C is 12, and D is 13. So we put D right there. And then we have to divide the quotient. So 2 divided by 16, that's just 0, remainder 2. So that's our answer in base 16. So let's actually now convert back. Let me just teach you, the last thing I want to teach you is just how to convert back from one of these number systems. So what was our binary answer? 1 0 1 1 0 1. Oh boy. 1 0 1 1 0 1. Actually, let me make this a little cleaner. Woo. 1 0 1 1 0 1. Whoops. Jesus Christ. 1 0 1 1 0 1. And I'm gonna, just to make this a little easier to see, I'm gonna put what place is each of these in. And we start from 0 and we work from right to left. So start from 0, we go to 1, we go to 2, 3, 4, 5. Why do we start at 0? Well, it'll make sense when I do this, because in reality what this represents is 2 to the 0, 2 to the 1, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5. So this makes more sense if you think about it in terms of, say, a normal decimal number. We're talking about 45. 45 is the number of the day. So let's look at this. 0 and 1. That's the 0th place, that's the 1th place. 10 to the 0, 10 to the 1. What we do is we say, okay, what's 10 to the 0? That's just 1. 5, and we have to multiply by whatever value its place is. Now the value of this place is 10 to the 0, it's 1. So 5 times 1. We have 5 of those, so it's, just 5 plus, and what is this? 10 to the 1, 10 to the 1, well that just equals 10. So 4 times 10 to the 1 equals 40, equals 45. So here, here's what we do. We say 2 to the 0, that equals 1. And we have 1 of those, so 1 times 1 is 1. We don't have anything here, it's 0 times whatever, we don't even care. So we just put 0. We're adding all of these. So, and now we have 2 to the 2nd, that's 4, and we have 1 of those. So this equals 4. Sorry for my handwriting. These are addition signs. Oh my God. That is so awful. Okay, so 2 to the 3, that's an 8. We have 1 of those. So 1 times 8, 1 times 8 is just 8. And 0, we don't really care because it's only 0 of those, so 0 times anything is going to be 0. And then 2 to the 5th is 32. So 32 times 1, because we have 1 of those, just equals 32. And what we do is we add these up. So we do 32 plus 8, that's 40, plus 4 is 44, plus 1 is 45. Ain't that cool? Now, let's convert the octal one. octal. In octal, it was just, let's see. In octal, it was just, oh man, why is that big? Okay, whatever. It was just 55. So let's do this. 0th place, 1st place. 8 to the 0, 8 to the 1. Because it's base 8. 8 to the 0 equals just straight up 1. So, 5 times 1 is 5. Now 8 to the 1 equals 8. So 5 times 8, that's 40. So what we end up having is 45. And that's it. And real quickly, the last thing I'll do is the hexadecimal. What was our hexadecimal answer again? It was 2D. 2D. Looks like two-dimensional. All right, so 2D. This is the 0th place. This is the 1th place. 16 to the 0, 16 to the 1. 16 to the 0 just equals 1. So 1 times D. Now remember, D represents 13. In hexadecimal, D just represents 13. So 13 times 1 is just 13. And then 16 to the 1 is just 16. So 2 times 16 is 32. Now, if you add up 32 and 13, you end up getting 45. And that is, I guess, all I'm going to do for today, or at least for this video. In the next video, I'll show you how to add these different number systems. The way I do it, I'll show you guys how to do that. But basically, this is all you need to be able to convert from binary to decimal to basically any number system and convert it back to decimal. And it's not pretty. It's not pretty and it's not efficient. And there are like faster ways to do it, but as far as an intro goes, or as far as having a foolproof way that will always work for you, this is how to go about it. And something I'm going to teach you in the next lesson is adding these things together. Whenever you're in doubt, you can come back to the basics, convert everything to decimal, add it up, and then convert it to whatever it needs to be. So I guess that's pretty much it for today. I guess I'll see you guys later.